lecture. Snippers. A sniffer is a packet capturing or frame capturing tool. It basically captures and displays the data as it is being transmitted from host to host on the network. Generally, a sniffer intercepts traffic on the network and displays it in either a command line or GUI format for a hacker to view. Most sniffers displays both the layer 2 or layer 3 headers and the data payload. Some sophisticated sniffers interpret the packets and can resemble the packet stream into the original data, such as an email or a document. Sniffers are used to capture traffic sent between two systems, but they can also provide a lot of other information. Depending on how the sniffer is used and the security measures in a place, a hacker can use a sniffer to discover usernames, passwords, and other confidential information transmitted on the network. Several hacking attacks and various hacking tools require the use of a sniffer to obtain important information sent from the target system. This lecture will describe how sniffers work and identify the most common sniffer hacking tools. Remember, the term packet refers to the data at layer 3 or the network layer of the OSI model, whereas frame refers to data at layer 2 or the data link layer. Frames contain MAC addresses and packets contain IP addresses. Understanding host-to-host communication. All host-to-host network communication is based upon the TCP/IP data communication model. The TCP/IP model is a 4-layer model. The TCP/IP model maps to the older OSI model with 7 layers of data communication. Most applications use the TCP/IP suite for host-to-host data communication. In normal network operations, the application layer data is encapsulated and a header containing address information is added to the beginning of the data. An IP header containing source and destination IP address are added to the data, as well as a MAC header containing source and destination MAC addresses. IP addresses are used to route traffic to the appropriate IP network, and the MAC addresses ensure the data is sent to the correct host on the destination IP network. In this manner, traffic is sent from source host to destination host across the internet, and delivery to the correct host is ensured. The postal system works much the same way. Mail is routed to the appropriate area using the zip code, and then the mail is delivered within the zip code to the street and house number. The IP address is similar to the zip code to deliver mail to the regional area, and the street and house numbers are like the MAC address of that exact station on the network. TCP/IP model are shown below. The address system ensures accurate delivery to the receiver. In normal network operations, a host should not receive data intended for another host, as the data packet should only be received by the intended receiver. Simply said, the data should only be received by the station with the correct IP and MAC address. However, we know that sniffers do receive data not intended for them. In addition to understanding network addresses, it is also important to understand the format of the TCP header. The TCP header is comprised of the following fields: source port 16 bits, the source port number; destination port 16 bits, the destination port number; sequence number 32 bits, the sequence number of the first data octet in this segment. If SYN is present, the sequence number is the initial sequence number, and the first data octet is ISN plus 1. Acknowledgement number 32 bits. If the acknowledgement control bit is set, this field contains the value of the next sequence number the sender of the segment is expecting to receive. Data offset 4 bits, the number of 32-bit words in the TCP header. This indicates where the data begins. Reserved 6 bits, reserved for future use, must be 0. Control bit 6 bits. URG, urgent pointer field significant. ACK, acknowledgement field significant. PSH, push function. RST, reset the connection. SYN, synchronize sequence numbers. FIN, no more data from sender. Thank you.